One of the things that we hear from a lot of facilities that we serve and a lot of facilities that have gone through our full day classes is that it's getting more and more challenging for mines and process plants to attract, retain, and develop the workforce that they need to make sure their plants and mines are operating correctly. Here's what we're going to talk about. We're going to talk about some of the basics of conveyors. We're going to talk about some of the problems of conveyors. And we're going to talk a lot about some of the really important componentries of conveyor belts. The basics of conveyors are simple as this. Conveyor belts are intended to move material in a bulk handling facility from point A to point B. It's intended to move that material from this location to that location. Now, I always say this in a live class, it's intended to move material from point A to point B, but in many situations, and probably your situations, it's intended to move material from point A to point Z because there's multiple conveyors. Conveyor belts typically operate at a lower cost than other options, most notably haul trucks. So conveyor belts are usually inexpensive, simple, conceptually simple pieces of equipment, but really, if you really dive into it, they're not all that simple. So think of a conveyor belt like a treadmill. They're very similar in that there's just some minor components that work together to move that belt. And we're going to talk more about that and then the intricacies of bulk material handling conveyor belts. It's a sum of the parts. So a conveyor belt is basically it's all these different components that come together, and when working properly, they perform well. But oftentimes, what you'll find is that if some of those parts aren't working, aren't performing properly, the overall system doesn't perform well. So let's talk a little bit about some componentry here with conveyor belts. I've grouped these components into 4 categories that I think is going to kind of help you understand the importance of each of these 4 categories of components. So the first component I would describe is found on most every conveyor belt. It's the must-have items of a conveyor belt. If you have these basic components, you have a conveyor belt. It will move material from point A to point B. And those are just what we just define as basic components. They're found on every conveyor belt, from a conveyor belt at a grocery store, a conveyor belt at an airport, and a conveyor belt at a mine or a process plant. It has these basic components. We're also going to talk about specialty components. Specialty components we're going to define as they're quite uncommon. You don't typically see them, but they're necessary in highly unique applications. If you don't have these specialty components, then you're going to have some problems with getting that material from point A to B or point A to C. We're going to talk a little bit about what we call performance components. Performance components are defined as critical components to successful conveying, especially when we're dealing with bulk material handling. Performance components reduce those unexpected problems or those unintended consequences that often come up with conveyor belts. They're often overlooked at the design of a conveyor belt. So let me give you an example. If I'm running a mine and my material changes, the production demands change. If the folks that are designing that conveyor don't take into consideration my needs at design, they'll often not include those performance components that I might need to add later on to make sure my conveyors are successful. Performance components typically have a very large ROI, meaning that if you invest in them, they pay for themselves very, very quickly. However, performance components might need some specialized maintenance that sometimes plant personnel may not have the knowledge on. And then finally, we're talk briefly about safety components. Safety components are often overlooked in specific industries. So depending on the industry that you have, the safety components that I'm going to mention, you may or may not have. You should consider all of them. Safety components must be inspected every 30 days. They should be inspected every 30 days and or tested every 30 days. So if you're not doing that, that's something that you might want to include in some of your procedures at your facility. All right, so let me give you some examples of each of these four types of components: basic, specialty, performance, and safety components. So those basic components, as we mentioned earlier, those are, kind of found on every conveyor belt. They would include the belt itself, the drive or the motor that creates the power for the conveyor belt. The structure would be included as one of the basic components. And then also included under basic components, I'm going to add what we call terminal pulleys. We're going to talk more about terminal pulleys in just a minute. And also transfer points. Now, transfer points is any time material goes from one conveyor to the other, or anytime material goes from a vessel to a belt, or vice versa, from a belt to a vessel. We consider those transfer points. That's when a material leaves one piece of process equipment to another piece of process equipment. Okay, some specialty componentry out there that you'll see that we're probably not going to have time to get into a whole lot today, but there's lots and lots of specialty belting. There's lots of specialty idlers. I'm going to talk a couple of minutes about some examples of specialty idlers. In some cases, you might need added vibration to keep material from hanging up on a bin or a hopper to help promote material flow. Sometimes some conveyors will have multiple or variable drives. And in rare instances, you might see what's called belt turnover stations. And on long, long conveyors that have a long run to prevent carryback, after the belt discharges, that belt will flip over and return back upside down to prevent that material from falling off on its return path. So just some specialty applications that are sometimes seen. Now, performance components, again, these are those make or break componentry that really reduce those unintended consequences with conveyor belts. It's those items that if you don't have, you can still move material from point A to point B. That conveyor will run without these performance components. However, it may not be a successful conveyor. You're probably going to increase your problems, and that's going to cause maintenance and operation staffs to have to react to some of those problems. So performance equipment is going to include belt scrapers, skirting systems. It's going to include inspection doors. If your conveyor is closed off, you should have inspection doors. It might include rip detection. Rip detection is a sensor that alerts the operators if the belt rips. You might include scales that weigh the equipment or weigh the material as it's being conveyed. Tracking devices to make sure that those belts track properly. Also, drive pulley lagging. Drive pulley lagging, we're going to talk a little bit more about here in just a minute. Tail pulley production, dust reduction, plug chute detection. All these are different types of performance equipment that really make the difference in successful conveying. Some safety components. Keep in mind, safety components should be inspected, should be tested at least every 30 days. Safety components might include emergency stop switches. There's a couple of different types of emergency stop switches. Sometimes you see simply a push button switch at the ends of a conveyor belt. A better option than that is a pull cord that runs along the full length of a conveyor belt. So if that pull cord is pulled, it'll automatically disengage that conveyor belt. Startup alarms, good practice to have a startup alarm to warn people when those conveyors are going to start up. Conveyor belt guarding, another really critical, important component that reduces injury around conveyors. And then crossovers for conveyors and backstops and brakes or conveyors are also considered safety components. So that's just a handful of different componentry, but categorized into kind of where they're most useful at. Not every conveyor belt needs safety equipment, performance components, or specialty components, but the more of those things that you add, the more successful the overall conveying is going to be. If you look at this diagram, this shows primarily some of the more important performance components. And I want to point you in the direction of some colors here. So we're going to look first at these grayed out pulleys. That's going to include the head pulley, the tail pulley, and then what we call the take-up pulley, bend pulleys, and snub pulleys. Now, most conveyor belts are always going to have a head pulley and a tail pulley. The bend pulley and the take-up pulleys, as well as the snub pulley, aren't quite as common as the head pulley and tail pulley. All conveyors, even my treadmill, which I don't use, have a head pulley and a tail pulley. A bend pulley and a take-up pulley, those pulleys work in conjunction with each other to keep tension on the belt. What happens in conveying is the drive creates power. It turns that drive pulley, and then that drive pulley with its lagging grips the belt and turns that entire conveyor belt. In order for that process to happen, that belt needs to be somewhat snug against that drive pulley. That tension on the belt is what creates that snugness to transfer the power from the drive to the head pulley. In order to keep that tension correct, in more complex conveyor belts, they'll use what's called a take-up. And there's a couple of different kinds of take-up. What you're seeing now is what's called a gravity take-up. And basically, this pulley, this take-up pulley that you see right here, moves up and down with weight. The more weight you put on that pulley, the more it drops down, which adds some snugness or some tension to the belt. The bend pulleys, and the intention of the bend pulleys is to send that belt into the take-up. Now, I want to mention the snub pulley as well, because the snub pulley also helps with that power transfer from the drive to the belt. What the snub pulleys are intended for, and not every conveyor will have this, a snub pulley's intention is to increase wrap around that drive pulley. When that wrap is increased, when the amount of degrees of wrap around that pulley goes up, you increase the friction, and that helps from the belt slipping. Now, you'll see some facilities from time to time, you'll have a belt slip where the drive will start, the pulley will turn, but it won't catch the belt, and a worker will get a shovel full of sand and toss that shovel full of sand up into that head pulley. What the intent is for the worker when they do that is to get some grit, get some material in there, and then increase that friction. Snub pulleys and lagging or a rubber wrap around that drive pulley kind of reduce that hazardous activity of throwing material up into that pinch point. So those pulleys, the head pulley, the tail pulley, the bend pulleys, take-up pulleys if they're found, and a snub pulley if they exist, are what we call terminal pulleys. We mentioned that earlier when we talked about some of the basic componentry. It's critical that these terminal pulleys all be aligned. The example that we have on the screen is a complex conveyor in that it has bend pulleys, take-up pulleys, and snub pulleys. If you don't have take-up pulleys, bend pulleys, and snub pulleys, then your only terminal pulleys are going to be head pulley and tail pulley. No matter how many terminal pulleys you have on the conveyor belt, if those terminal pulleys are not aligned, you're going to have some significant belt mistracking. So it's really important that terminal pulleys be aligned. Now let's move on to the orange components that you see. And these orange components are really some of these performance components that really make or break a conveyor belt. We'll start at the head pulley, and I want to point out the primary cleaner, the secondary cleaner, and in some cases, you might see what are called tertiary cleaners. So I'm going to talk more about those here in just a couple of minutes. Towards the back end, towards the tail pulley, I want to point out tail pulley protection plows. These are a pretty uncommon performance components, but they're really important. What a lot of facilities do, especially in the aggregate industry, is instead of using a steel tail pulley, they'll use a winged tail pulley. Winged tail pulleys put a lot of stress on the conveyor belt, and over time, they can damage the conveyor belt. It's also very difficult to seal spillage and dust at a transfer point when a facility insists on using winged tail pulleys. Now, the intent of a winged tail pulley is to prevent damage if a piece of material were to get wedged in the pinch point between the belt and that pulley. So if I had a piece of material fall on the belt right here, it get pulled into this pinch point, it could damage the belt. On a winged tail pulley, less likely to damage the belt. That's why a facility might use a winged tail pulley. But what they often overlook is the other problems that that wing pulley creates. As I mentioned, damage to the belts and a reduction in dust control. So a better option than using a winged tail pulley is to use a traditional steel pulley and protect that pinch point with tail pulley protection plows. So that's just a little unique piece of performance equipment that really prevents some of those unintended consequences. And then you'll also notice in the orange some components, tail boxes to prevent dust, dust seal, skirt boards, slider beds, and impact beds. Those are all some of the more unique pieces of performance components that you may or may not see, but increase the conveyor belt's performance. We'll talk a little more about some of those things here in just a minute. I need to take a closer look at the head pulley itself because it's such an important piece of equipment. Head pulleys is where a lot of problems can come up with. Again, that's a terminal pulley. It's got to be aligned with the other terminal pulleys. Your drive is typically located at the head pulley, but not always. So it's important to note that the drive pulley is often found at the head pulley. However, there are conveyors that might be driven from a tail pulley or the center drive as well. Whenever you have the drive, you're also probably going to include lagging. That lagging, if not maintained properly, can cause some belt tracking problems. You'll also often find some chute work. You've got to be concerned with material building up on that chute. And you're also going to see belt scrapers installed at the head pulley, and often we would include inspection doors. So if you're not familiar with inspection door, in some industries, if that head pulley is enclosed, if you don't have those inspection doors, you can't get in there to inspect belt cleaners or lagging or some of the other components that might be in there. Now, those doors should be large enough, like this example, where a worker can access components, but before they access those components, you want to make sure that they tag out that conveyor belt. So inspection doors, access doors, some terminology there that you might run into if you're going to access those components. Got to make sure that those are locked out and tagged out. Just real quick here on belt scrapers, and I'm not going to get too in depth into this. Earlier, I mentioned secondary cleaners and tertiary cleaners. Typically, tertiary cleaners and secondary cleaners are on the return path further down in this area here, which we call the secondary zone. Most conveyors are going to have at least a primary cleaner In some instances, in many instances, a primary cleaner will not eliminate all the carryback that's needed to eliminate. Therefore, secondary and tertiary cleaners can be added. All right, let's take a little bit of a closer look at transfer points. Again, another really important, critical part of a conveyor belt where a lot of problems can happen. In that transfer point, you'll often see what we call the tail pulley zone, and that's the area as the belt comes off the tail pulley. So the tail pulley zone would be in this, the red area would be the tail pulley zone. The blue area, we'll call that the head pulley zone. And then the settling area is after the material loads onto the belt. So this would be considered the impact zone. After the impact zone, which includes the drop chute, is what we call the settling zone. Okay, the settling zone is really important. You'll find tons and tons of performance components in that settling zone. The intent of the settling zone is to ensure that material and dust settles before it leaves this skirted area. All right, a closer look here at idlers. I want to mention to you carrying idlers, another one of those really important pieces of componentry that every conveyor is going to have. On the left-hand side, you see a couple of different types of carrying idlers. Now, in the United States, there's 3 different degrees of carrying idlers. The intent of a carrying idler or a troughed idler is to take that flat belt, trough it, which increases its capacity. You can pile more material the deeper the trough. Some belts are flat. They're going to have the least capacity. In the US, there's 3 standard troughing angles. There's 20 degrees, there's 35 degrees, and there's 45 degrees. That refers to the angle between the winged pulley and how the belt would lay flat. This angle can be one of these 3 troughing angles in the States: 20 degrees, 35 degrees, and 45 degrees. In most facilities, you're going to see 35 degrees. However, in some facilities, you'll see 45 degrees. In some, you'll see 20 and 45. But most common is 35-degree idlers. Now, you see in the 2 examples here on the top and the bottom, a steel roll and also a rubber roll. In some instances, in the impact zone of a belt conveyor, in the point where the material's loading the belt, that impact zone, some facilities would use a rubber roll or an impact idler like you see on the bottom, and that just helps absorb the shock of the material as it loads the belt. On the right-hand side of your screen, you're seeing some return idlers. In most cases, those return idlers are going to be flat like you see on the top, but in some cases, you'll have a V return like you see in the bottom, and the intent of a V return is it helps increase the belt's trackability. We're not big fans of return rolls that are shaped like a V like you see in the bottom, but you will see them. They're not real effective in tracking the belt, but some people believe in them. A better option in tracking the belt is to use some of those belt tracking equipment that you can see on the market, and then making sure that your componentry is aligned and you're not off-center loading. All right, let's talk a little bit about belting itself. So there's lots of specialty belting that's out there, and basics of belting are quite simple. There's a rubber top cover, there's a rubber bottom cover, and there's fabric plies that are sandwiched in between. The strength of the belt comes from those plies. Those fabric plies are usually a synthetic material. They're man-made. 40, 50, 60 years ago, they were cotton. But now with the synthetic materials that are out there, polyester, polypropylene, nylon, and the way they're woven, those fabric plies now are much, much stronger. They'll resist rot. They'll resist moisture much better. The top cover, the intent of the top cover and the bottom cover is to provide a smooth protective surface or uh, a protective coating to those fabric plies. So just a couple of basics on belting there for you. One of the really important functions of the belt is that it be spliced correctly. Mechanical splice is pretty common. However, you've got to be very concerned with mechanical splices and how they work with belt scrapers. If they're far off the belt, if they protrude off the belt surface, they're going to cause problems with belt scrapers. A really unknown and underappreciated concern with mechanical splices is how they might interfere with sealing at a transfer point. And I chose that particular picture on the left to show how a skived belt may or may not work appropriately with skirting systems to seal in dust. So you want to make sure that if you're skiving that belt, you keep that consistent level with the belt as much as you can. In the picture that you see here, dust could escape, and that could cause some problems. Another concern is if that splice protruded far off the surface of the belt. As that splice comes through, it will lift up that skirting, and that also could cause dust to escape from that sealing system. So you want to make sure that any mechanical splice is skived so it's as close to the surface of the belt as possible. Now, a better option is to make sure that you're vulcanizing those splices. So there's some added cost in vulcanizing the splice, but those vulcanized splices aren't going to impede with belt cleaners, and they're not going to impede with dust at the transfer points either. All right, let's talk a little bit here about some problems. Some of the biggest problems with conveyors are downtime, maintenance, fugitive material, and risk of injury. There's a study that I refer to. It was done by the U.S. Bureau of Mines. And in that study, they said that 42% of the injuries that they found around belt conveyors were from the workers performing maintenance, lubricating, or checking a conveyor. 39% of the injuries that they found from conveyors were from workers shoveling or cleaning around conveyor belt. So 40%, 39% of conveyor injuries from a study done by the U.S. Bureau of Mines indicates that the worker was hurt from cleaning and shoveling materials, cleaning and shoveling spilled materials. So you want to make sure that that material is kept on the surface of the belt as possible. I want to share this with you. This is really important. This is something that you really got to recognize here. There's 4 different belt speeds that you see here, indicated with 4 different colors. The blue is 200 feet per minute. The fastest example that we have is the black, the top line, which is a belt that runs at 1,000 feet per minute. The bottom, the numbers at the bottom represent the human's reaction time, or said differently, the time that it takes a worker to drop a tool. Here's what this chart can help your workers with. If you've got a human reaction time of 0.8 seconds, and that's the average reaction time that we've measured. So for one of our publications, we did some tests. We measured how long it takes the brain to send a message to the hand to open the hand, and on average, it was about 0.8 seconds. So if you've got an average reaction time of 0.8 seconds, and let's just say your belt runs at, let's say, 800 feet per minute. If one of these 2 lines intersect, if you come over here to the left of this chart, that tells you how far that belt will move in the time that it takes a worker to drop a tool. So in this example of 0.8 seconds and a belt that runs at 800 feet per minute, before a worker can let go of a shovel or a broom that he might be using to clean around a conveyor belt, before he can go like this, that belt's already moved 10 foot. So pretty significant risk here with fugitive material. We want to make sure you minimize fugitive material as much as possible. So I want to talk a little bit more about problems with conveyors, in particular fugitive material. There's three types of fugitive material. Carry back, which is seen on the left. That's material that sticks to the belt after the return point and builds up on rolling components, creates belt tracking problems, creates premature equipment failure, creates excess cleanup for workers. Spillage, that's when material doesn't load properly onto a receiving belt. Again, increased cleanup, increased risk, increased cost of operation to the facility. Lots of performance components that can be added to completely prevent spillage. Spillage and carryback have huge return on investments. And what I mean by that is the cost to resolve those two problems is incredibly minimal compared to the cost of reacting to those problems. So if you're living with spillage, you're living with carryback, make sure you dive into those components, those performance components to prevent those. The third is dust. Now, we got to pause here and talk a little bit about dust because just this morning, MSHA has announced the new rule on acceptable silica dust in the mining industry. For some time, MSHA has been discussing and proposing a new rule on how much dust is acceptable in the mining industry. And truly, moments before we came on the air here with this webinar in Union, I think it was Unionville, Pennsylvania, the Secretary of Labor, Julie Sue, as well as MSHA Assistant Secretary Chris Williamson announced the final rule on dust control, and it's going to be more and more challenging to control dust. So that's a concern. If you don't think you have a dust problem now, you may have a dust problem tomorrow. Now, if you think you already have a dust problem, your problems become much more complex. Now, one of the things that MSHA mentions in their rule is that you must use engineered controls to control dust. And I got to mention this to you. There's three engineered controls. There's suppression, the collection, and what we call containment. Suppression is adding water, or sometimes water with a chemical or surfactant to suppress the dust. Collection techniques would be dust collection systems that extract dust from the process. However, containment is simply using the performance components that we talked about earlier to slow down the airflow and let the dust fall out of suspension. I can't be any clearer on this than what I'm going to say next. If you have a dust problem and you're looking at containment as a solution, good for you. If you have a dust problem and you're thinking you're going to resolve that with suppression by water sprays or collection sprays, you are about to take a journey in unintended consequences. Performance components. Go back to the basics here. This is Conveyors 101, gang. Make sure that you fully look at all those performance components when you have dust problems. Performance components, sealing systems, dust curtains, slowing that airflow down. Don't add water to your process. If you do, you're going to have those unintended consequences that you're not aware of quite yet. You're going to cause material to stick to screens. If you add water, material is going to stick to the side of hoppers, and you're going to have to react to those problems. Focus in on those performance components that we talked about earlier.